In this lecture, I would like to share the concern when you have choosing a CAD/CAM equipment. It's been 35 years since CEREC 1 opened the digital dentistry in 1985. From CEREC 3D, BlueCam, OmniCam to PrimeScan, I first encountered CEREC 15 years ago. Sirona CEREC was the true modelless digital solution for intraoral scanner until 8 years ago, but as 3D technology has become a lot more standardized recently, a wider range of digital equipment has become readily available to enable modelless clinical treatment. Then what should you considering when deciding on CAD/CAM equipment? Most of the CAD/CAM dental equipment focused on restoration aspect. On the other hand, in the field of orthodontics, an intraoral scanner that can accomplish full mouth scans is mandatory rather than the one that has more accuracy on fragment. Also, you must analyze whether you'll be focusing more on one-day visit restorations or zirconia restorations, especially for implant patients before deciding on a milling unit. You can basically divide the chairside dental CAD/CAM equipment in two different types. The first necessity would be an intraoral scanner and CBCT in order to import the data in any modelless dental practice. The second is a milling machine and a 3D printer to export the data. And chairside CAD/CAM dental equipment can be characterized as either a color intraoral scanner that is practical for full mouth scan and a CBCT with FOV size bigger than 8 by 8 cm. After a successful data input, the data exported to a CAD software either in DICOM and STL. The newer version of intraoral scanners are not superb in resolution than conventional level impression and have less than 50 micrometers in full arch distortion. The CAD software is very important part because the software selection is equivalent to selecting the treatment method. In the CBCT, the DICOM has been in use for a long time, but the intraoral scanners STL and PLY is still fairly new. The STL and PLY file conversion recently arose when Sirona's intraoral scanners began supporting both files. Each intraoral scanner company mostly provides STL converting feature. Any technicians design on any CAD software through a SD file regardless of the type of intraoral scanner. So we no longer need to purchase and learn each different company's software. The left is on scan data of Sirona OmniCam, and on the right is orthodontic diagnosis using 3-shape orthoanalyzer. As you can see, the conversion to a STL file is perfect except for the color information. In the past, we had to select an intraoral scanner first and then purchase the CAD software, but now it is the exact opposite. The color data is illustrated on the left and the solid color of the converted SD file is shown on the right. The accuracy of an intraoral scan is sufficient, but the resolution is still insufficient. So it is difficult to distinguish the circus line separated by a single chord. Hence, color data plays an integral role for restorations using intraoral scans because it is apparently difficult to find margin on the solid color data on the right side. It is useful clinically to use a PLY file with color information as much as possible. Next topic is the guided implant surgery. On the left is 3Shapes Implant Studio and right is Sirona's CEREC Guide 3. We must merge the two sets of the data at the teeth using CBCT and an intraoral scanner. We can design the virtual restoration on the STL file and finalize on the anatomically ideal location of the fixture using on DICOM data. Lastly, we create the bite spline, which will guide the drilling location, including the sleeve hole. Many companies are investing and researching, but there are the only two products that guarantee the merging of CBCT and an intraoral scanner. And it is a given that both CBCT and the intraoral scan data must be good set of data for perfect merging. Yet these two software have two different goals. Implant Studio enables designing on any type of CBCT and intraoral scans. On the contrary, Select Guide 3 can only design using the data generated by Sirona's product, which guarantees the most optimized resolution and merging result. Unless you own both of the equipment, you can't use this. The CAD software, which can be mainly divided in processes, implants, and orthodontics. A virtual 3D processes has been designed. You proceed on to the fabrication stage. Previously mentioned, this section of CAD software is equivalent to the selection of digital treatment. Personally, I purchased 3Shape software for orthodontic treatment about 6 years ago, and currently I treat my orthodontic patients digitally using the converted STL files. Sirona software focused on restorative and fixed processes, including implants. Its biggest advantage is that a single software operates all of the process and is very user-friendly while along a one-day treatment. 3Shape differs from Sirona with its biggest selection of CAD software application of digital dentistry. XCAD is a software that emphasizes restorative fixed prosthodontic, including implant processes. The last stage is the fabrication. Fabrication consists of milling, grinding, 3D printing, CNC, and robotic bending. Most commonly, milling or grinding is used for conventional restorations. CNC fabrication for implant abutment, 3D printing for guided surgeries and orthodontics, and robotic bending for orthodontic wires. The equipment really depends on digital treatment type and the quality. Select grinding fabricates with 3 of the 2 axes. This method is very similar to 4-axis milling. This uses 2 of the diamond tool with a step shape that will gradually, and it's relatively a very stable and fast way of milling with 35 years of history. It takes less than 7 minutes for an inlay and no more than 15 minutes for a crown. 4-axis milling machines recently began ceramic grinding in 30 minutes, but ceramic grinding is more attractive for ceramic milling considering the overall time efficiency and milling safety. One of the biggest disadvantages of ceramic milling unit is that it is a closed system that can only be connected to a ceramic software. If you use a different CAD software, you have the option to select either inlet milling unit or Amman-Gilbert or Flatmakers, among many others. This shows a 4-unit anterior veneer case using the latest material of GLS. It is recommended to treat veneer patients same day because temporization. You can accomplish this within only 3 hours using inlap MCXL. You can see the original veneer has fallen off on tooth number 22 on the before treatment. It is especially useful to keep record of before treatment scan for those patients who want an aesthetic result. You can edit the texture on the final design after making the anterior teeth about 1 retracted. You can now do minimum polishing and glaze on the aesthetic restoration. This is a direct comparison of before and after digital data and the intraoral photos. This type of treatment is achieved using a different scanner and a CAD software, but the milling unit has to be a static grinding unit. Carbide bar milling has its own benefits to zirconia, PMMA, polymer fabrications. 5-axis milling strategy would result in a safer and precise milling. Modelless restoration and implant processes definitely require a 5-axis CAM software with a 5-axis milling unit. In Prime Mill, which is new this year, the super fast mode that allows milling in 5 minutes for a single unit crown has been created. It is attracting attention for treatment purpose on same day. The Ultra Trans Zirconia is a new frameless veneer. Case selection is important in this case. This is the case with small teeth and diastema. Ceramic material cannot be milled under 0.5 mm, but in this case of the 5-axis processing milling and zirconia, milling up to 0.3 mm is possible. In this case, it can be adhered to proximal and can be overcome with MDP adhesive and sandblasting. However, the anterior guidance has to be properly adjusted. Here is a temporary Maryland bridge. PMMA disc material has 2 to 3 times the strength of the existing temporary material. It can be used very useful for the temporization of the one tooth defect up to premolar region. Resin cement is used for bonding, and it can be used without problems for about 3 months. This case was used for maintenance period after extraction and socket preservation and before implant placement. Recent milling motion do support simultaneously 5-axis milling. It is very important to select a product that can reliable milling process. Another key factor is the installation environment, because they need a separate compressor. So you need to carefully plan out floor plan of your cleaning space. Dry milling unit is only milling of soft material such as PMMA and zirconia. Wet milling units are large and the installation conditions are difficult, but it is possible to mill ceramic, titanium, and chrome cobalt metal as well as customized abutment. The design and fabricate of an abutment and a crown at the same time is most ideal modelless process. But the hard part is to fabricate abutment with less than 50 micrometers cement gap to have them fit with the prefabricated crown due to inaccurate milling of the abutment. Recently, we have seen changes through advanced CNC milling process. This is a posterior missing case. The patient was scanned a week after the second surgery using scan post and Omnicam. We made sure that there was no bone or tissue engagement to scan post through an X-ray examination and confirmed that scan body clicked into their correct position with a tactile sense. These are scan post and scan bodies on the actual patient. Left is scan post, right is a scan body. Using a full mouth scan, we design implant processes in its final shape on both sides and split up the abutment and the crown. You can design your restorative component while assuring the functional guidance and the occlusal contact. The turnaround time of CNC abutment is 2 days based on Korean time. You will see and experience the consistent and reliable fitting of the prefabricated zirconia crown abutment. The actual delivery time is less than 5 minutes per unit. Here you can clearly see the perfect margin fit among the fixture, the abutment, and the crown through these X-rays. 3D printer used in dentistry use UV light polymerization resin. There are three types of UV light source: the DLP method using a projector, and SLA method using a laser, and the LCD method using an LCD mask and UV lamp. The most commonly used method is DLP. DLP is direct light processing. It's advantageous in terms of light intensity and speed. And SLA has strong light intensity, but it is difficult to control and take a long time. LCD has the disadvantage of having to repair frequently due to lack of light, and the lifetime of LCD mask, which acts as a shutter, is only several months. These are two most popular CAD software for digital orthodontics. The left is Maestro and the right is OrthoAnalyzer, which enables model diagnostics and the output of a stereo model for digital clear aligner. You can perform full mouth scans and also work with any scanners that allows you to export the files in STL. There has been a huge improvement in IntraScan for more accurate diagnosis and data management, easy setup model, and even the digital clear aligners within the world of digital orthodontics. The left photo illustrated a very simple treatment using a digital clear aligner produced with an IntraScanner. After digital setup to movement, we made clear aligner using sheets made of thermoplastic. The photo on the right shows smile, which makes the setup model according to the arch form. Then bracket was positioned and 3D printing indirect bonding IDB trays, so we can bond them indirectly and intraorally. This is a summary of the most ideal modelless workflow depending on different fabrication categories. The most appropriate for ceramic is CEREC grinding unit, and for zirconia and polymer, 5-axis milling unit would work the best. But for titanium abutment, it would be wiser to outsource for CNC milling. Lastly, a 3D printer is necessary for orthodontics and implant guides. This is a list of equipment organized by milling strategy. You would have to review milling table and speed in order to decide on a CEREC grinding equipment, whereas the stability and flexibility on various milling material and shape would the biggest concern for 5-axis milling unit. Also, please don't forget that CAM software could be the more important factor rather than the milling machine itself, because the result from a single machine could be totally different depend on the software. I understand that decision making for 3D printer is a tough one, even though it is fundamental in all orthodontic treatment. 3D printer market is growing as faster as the Moore's law state. I would recommend to try out a printer that costs under $10,000 depending on your needs. To sum up, intro scanners have already partnered up with CAD software, and you must decide on that CAD software after analyzing on your desired method of digital treatment within your budget. I think it makes sense to decide on the fabrication stage, strategy, and quality after deciding on that desired method of treatment. I hope you find my 30-minute presentation helpful when deciding on your future digital equipment investment. Please send any question to the email address below. Thank you very much.